Today I'm going to take you in the world of chemistry, more concepts to be precise. But before we start our lessons, kindly hit the notification button and turn on notifications for new videos. So, our question for today reads, magnesium oxide reacts with dilute sulfuric acid as shown below. So magnesium oxide reacted with dilute sulfuric acid producing magnesium sulfate and water. 600 grams of magnesium oxide reacted with 980 grams of dilute sulfuric acid. Question A. Determine the limiting reagent in the reaction above. Well, ladies and gentlemen, I know by now we all know that a limiting reagent is simply a reagent which is in short supply by mole ratios. Meaning that for us to answer this question, we have to calculate the number of moles of magnesium oxide and then compare them to the number of moles of sulfuric acid. How do we do this? This is how we answer this question. So we'll say solution. Solution N. So use the formula number of moles. So we're going to calculate the number of moles of magnesium oxide is equals to mass over molar mass, like that. So number of moles is equals to the mass of magnesium. Here we have been given 600 grams of magnesium oxide. So magnesium oxide, the mass is 600 grams. We're going to write the mass of magnesium oxide like that. Then we divide it by the molar mass. Molar mass, this is simply the sum of all relative atomic masses. So how do we calculate the molar mass? This is what we do. We're going to calculate the magnesium. We're going to write magnesium oxide chemical formula like that. Then we calculate its molar mass. So this is how we calculate the molar mass. How many atoms of magnesium do we have here? We have one atom of magnesium. So we're going to write 1 multiplied by, what is the mass number of magnesium? The mass number of magnesium is 24. So we're going to multiply 1 by 24 plus, open bracket. How many atoms of oxygen do we have here? We have one atom of oxygen. So we'll say 1 multiplied by 16, which is the mass number of oxygen. So 1 by 24, that's 24. Added to 1 by 16, that is 16. So what is 24 by 16? You have to use a calculator there. If you're not sure, you can say 24 plus 16, giving us 40. So the rate molecular mass of magnesium oxide there is 14. Then we're going to divide this 600 here by 40, like that. So the number of moles of magnesium oxide here, we're going to say 600 divided by 40, that is giving us 15 moles. So here we have 15 moles, like that. Second, we're going to calculate the number of moles of sulfuric acid so that we could compare the number of moles to see which one will be limited and which one will be in excess. So we'll say number of moles of sulfuric acid, like that, is equal to mass over molar mass. So number of moles is equal to, what is the mass of sulfuric acid? In our question here, we have been given the mass 980 grams of dilute sulfuric acid. So the mass is 980 grams, like that. So we divide that by the relative molecular mass of sulfuric acid. We're going to use the same procedure just like the one we did for magnesium oxide. So we'll say sulfuric acid, we'll write it down like that. And ladies and gentlemen, you have to be aware of the chemical formulas. You write it like that. Then we start calculating its relative molecular mass. So we'll say how many atoms of hydrogen do we have here? We have 2 atoms of hydrogen. So we'll say 2 multiplied by, what is the mass number of hydrogen? 1, close, plus, open bracket. How many atoms of sulfur do we have here? We have 1. So we'll say 1 multiplied by the mass number of sulfur, which is 32. Close. Ladies and gentlemen, these numbers I'm writing, these are the mass numbers. You can use the product table if you're not sure. Plus, open bracket. How many atoms of oxygen do we have here? We have 4 atoms of oxygen. So we're going to multiply the 4 by 16, which is the mass number of oxygen. So 1 by 2, that's going to give us 2. Say plus 1 by 32, that's going to give us 32. Plus 4 by 16, use your calculator, say 4 by 16, that's going to give us 64. You write your 64 like that. And then from there, you add those together, which is 64 plus 32 plus 2, giving us 98. So we write our 98 like that. So we're going to divide that relative molecular mass by the 980. So we're going to say 980 divided by 98, giving us 10. So number of moles of sulfuric acid is equals to 10 moles. So now when you reach this stage, ladies and gentlemen, we simply have to use our eyes and compare which one is limited and which one is in excess. So here, ladies and gentlemen, we can tell as in like sulfuric acid is limited simply because the number of moles are less compared to the number of moles of magnesium oxide. It is in short supply. So we can conclude by saying therefore sulfuric acid is the limiting reagent. So say sulfuric acid is the limiting reagent, like that. Limiting reagent. So we have answered the first question there. Calculate the mass of magnesium sulfate that was obtained at the end of the reaction. Calculate the mass of magnesium sulfate that was obtained at the end of the reaction. Ladies and gentlemen, when calculating the mass here, we always use the this limiting reagent that we have come up with here, which is the sulfuric acid. That's the one we're going to use in order for us to come up with the mass of magnesium sulfate, which they are requesting us to come up with. So we'll say sulfuric acid, which is limited to the ratio of the magnesium sulfate which they want us to calculate. This is the magnesium sulfate they're talking about. So we'll say magnesium sulfate, like that. And then, what is the mass of sulfuric acid? Sulfuric acid have been given 980 grams. So we're going to write 980 grams of sulfuric acid. And then what is the mass of magnesium sulfate? This is the mass they are requesting us to come up with. So we'll just say M, symbolizing the mass. So when we reach this stage, ladies and gentlemen, we are going to calculate the relative molecular mass of sulfuric acid. But lucky enough here, we already calculated it, which is 98. So in simpler terms, we're just going to write 98 there to the ratio of what is the relative molecular mass of magnesium sulfate. So we're going to calculate the relative molecular mass of magnesium sulfate. How many atoms of magnesium do we have here? We have 1 atom of magnesium. So we'll say 1 multiplied by what is the mass number of magnesium? That's 24. Close, added 2. How many atoms of sulfur do we have here? We have 1 atom of sulfur. So we're going to say 1 multiplied by what is the mass number of sulfur? That is 32. Close, plus, open bracket. How many atoms of oxygen do we have here? We have 4. So we can say 4 multiplied by the mass number of oxygen, which is 16. Like that. So 1 by 24, that is 24. 24 plus 1 multiplied by 32, that is 32. Added 2. What is 4 multiplied by 16? You get your calculator. We'll punch 4 multiplied by 16, giving us 64. So go and write our 64 like that. And then when you reach that stage, you simply add all those numbers together. We'll say 24 plus 32 plus 64, giving us 120. So we'll say 120. 120. So this 120 is the relative molecular mass of magnesium sulfate. We'll write it there like that. And then we'll write the mass of sulfuric acid, which has been given already, with the M, which is the mass of the magnesium sulfate we are calculating. When you reach this stage, ladies and gentlemen, you simply cross multiplication like that, and then we'll start multiplying. We'll say, what is 98 multiplied by M? That's going to give us 98M equals to 980 multiplied by 120. So you get your calculator, you punch 120 multiplied by 980. That is giving us this figure. So you write it down the way it is. And then from there, ladies and gentlemen, we are going to divide both sides by 98, making M, which is mass, the subject of the formula, by 98 even that side. So in this case, our mass is going to be, we divide this, our answer, by 98, giving us 1,200. So here we have 1,200 grams of magnesium sulfate, like that. That's how you answer that question. And then we have our last question here, which reads 1,080 grams of magnesium sulfate was obtained at the end of the reaction. Calculate the percentage yield. 1,080 grams of magnesium sulfate was obtained at the end of the reaction. Calculate the percentage yield. Well, ladies and gentlemen, to calculate the percentage yield, you use this formula. We'll say percentage yield is equal to actual yield over theoretical yield. Multiplied by 100%. Well, some of you probably asking where this 100% is coming from. This 100% is coming from the percent sign that we have here. So that percentage simply means 100. So in our question, they're saying 180 grams of magnesium sulfate. So this 180, that is our actual yield. So here we'll simply say yield, meaning the percentage yield in general, is equals to 180 grams over the theoretical yield. This is the mass which we obtained here, which is 1,200. So write 1,200 like that, multiplied by the percentage, which is 100%. So yield in this case is equals to, you get your calculator and then you punch 1,080 divided by 1,200. That's giving us 0.9. So this 0.9, we're going to multiply it by the 100% like that. So our yield is equals to 0.9 multiplied by 100, giving us 90%. So the percentage in this case was 90. When you reach this stage, ladies and gentlemen, you have answered the question. My names are Bisesa, and you happen to have any questions, kindly write them down in the comment section, and Mr. Muntanga will get back to you. Thank you.